Turning to the next set of topics for remote sensing, we're going to talk about visual interpretation of aerial imagery. Visual interpretation might seem like sort of a basic or old-fashioned approach, but really being able to look at images and judge what you're seeing, both in terms of identity and significance, is still an important part of remote sensing. So I always start with this image. It is, trying to see what it is. One thing you should be able to notice is that around the edges, there are what appear to be cars, car parking lots, a lot of car parking lots. And then there's this round or oval area that is vegetated, and it's got like a little, looks like an artificial river. It's not a river because you can see it comes to, it starts and stops at the same elevation. I've zoomed into the middle, and there's some kind of structure that has circular, and it looks like maybe it's pathways. I usually ask in class, I would ask, and someone usually gets, this is Disneyland in California. So until recently, we wouldn't have said visual interpretation of aerial imagery. We would have referred to photo interpretation. So the act of examining photographic images for the purposes of identifying objects and judging their significance. Now we look at a wide range of types of visual media, including especially digital images collected by satellites. So now we just talk about the act of examining images for the purposes of, again, identifying objects and judging their significance. Note that the types of images that are appropriate for photo interpretation are those in which objects are clearly visible, as opposed to, say, moderate and low spatial resolution satellite images. Visible doesn't have to be that you can see every, you don't need to see every tree to see a patch in the forest, and we'll talk about that in a bit later. But you somehow have to be able to make that visual connection to what's on the ground. For a while, I think image interpretation had a bad rep, as an outdated discipline that one would be replaced by objective methods based on automated methods. That really hasn't occurred because the sophistication of automated methods, including things like object-oriented classification, hasn't caught up with that of the human eye-brain combination, or at least it hasn't caught up to it yet. So for instance, tree crown delineation is a big application that you might have from high spatial resolution imagery. Well, it's actually pretty hard to do because you have shadows in forests, you have a variety of different tree sizes, you might have dead trees. So it's a lot easier said than done. And even when you're dealing with complex digital analyses of global scale conditions, very often what you'll find is that they depend on visual interpretation to create the training data needed to run automated methods. And I'm thinking here of the global maps of forest cover that Hansen et al. Have put together. These are global maps based off MODIS data, so coarse spatial resolution, 250 to 1,000 meters, but the way they train that information to get the data product is to look at Landsat data at 30 meters, which allows them to identify, and actually they use students to do classifications and identifications of the forests in the higher resolution data, and then that information is used to classify the MODIS data. In many cases, you could use an automated approach or visual interpretation. Each might be equally suitable. The automated approach may be the more interesting one to do, but the visual interpretation approach may just be less expensive. If the goal is exploration of new methods, then the automated approach may be appropriate. But if the goal is just the development of a data source, the second may be the best approach. And, if you were creating a forest map for the areas around Pingree Park, for instance, Mountain Campus, then you might just decide that you'd be able to get more detailed information from photo interpretation and create your map that way. So there are 7 conditions that indicate when visual interpretation is most appropriate. So one is a necessity. It has to be able to relate features delineated in the image to coordinates in a conventional projection. So if you can't in some way register the image to a set of geographic coordinates, then there's really no way you're going to be able to use it in a GIS context. Examples of imagery like that, it might be oblique imagery, where the area that you'd be interested in would be further away, and so it would be very difficult to do the registration. The others are conditions when visual interpretation is especially useful or necessary. So when you need detailed spatial information for the analysis, and what I mean there is, when you need to be able to get a detailed level of information for the objects that you're identifying. That would be one area where this is especially useful. For instance, go back to the stand information or stand mapping approach for Pingree Park. You might be able to do that with an automated method, but the number of attributes that you would be able to derive would be less than if you were actually doing a visual interpretation, because you'd be able to see each stand in the context of other stands, and you might be able to see for just one or a few stands that there were obvious examples of management practices. So these are things that you wouldn't necessarily be able to train a classification approach because you've only got a few examples, but it might be obvious using visual interpretation. When you want detailed taxonomic, I've got that in quotes, information. So if you want levels of detail where, you want to be able to put each cover class that you identify in the context of a larger classification with coarser levels, that might be a reason to do visual interpretation. When judgment is required. So for instance, actively grazed rangeland looks a lot like shortgrass steppe, especially, when everything is brown out there. So they look the same spectrally. However, if you can see that the area is clearly fenced off, it has infrastructure that you would need for pasturing cattle, a certain pattern of roads might be indicative. You'd be able to make that distinction without which you wouldn't. For some cases where visual interpretation is especially useful, when you want to look at qualitative change, for instance, at some spatial resolutions, coarser spatial resolutions, not very coarse, but like 10, 25 meters, old residential neighborhoods appear to be similar to young forests. So if you think of the area west of Old Town in Fort Collins, and some areas in Boulder, the older areas, you have very high percent tree cover. And so a naive automated classification might tell you that that's young forest. That's not a mistake you're likely to make if you're actually doing visual interpretation. When historic context is important, even with high spatial resolution imagery, automated approaches can't interpret differences in the spatial pattern of residential development in such a way to allow you to estimate when a residential area was developed. And so I'm thinking particularly in the United States, you can tell pre-war versus post-war residential building because, I'm sorry, World War II, pre-World War II, post-World War II. You can tell the difference because they switch from gridded streets to the more curving suburban layout that you see, that you're probably familiar with. If the area is small enough that it can be covered with available resources, so there's no point in getting the best possible data for half the area of interest. So automated methods are really generally cheaper for larger study areas where it makes sense to put in the time for training data. But if you just don't have the data, then there's no point in getting aerial photography when something else covers the entire study area. The next thing we'll talk about are requirements for visual interpretation of images. So the images themselves have to be of an appropriate spatial and spectral resolution. You need the correct tools for the task. The right tool can easily, double or quadruple your production of information about the photos you're trying to get. Training is extremely important. Ancillary information, possibly including fieldwork to actually discover what you're looking at. And finally, you need knowledge of the topic area or a topic or area. That is, if you're going to do soil boundary delineation, you're going to have to know an awful lot, not only about soil science in general, geomorphology, but also the soils of the area that you're interested in and how they tend to co-vary with the geomorphology. And finally, you need experience. It's one of those things that, you start out and it's very difficult to figure out for some people, not everyone, but for some people, it's very difficult to figure out what they're looking at, just because it's hard to at least initially make the connection between, this texture is associated with forest, and it sort of over time makes sense. Okay, so this is a large crown, this is a small crown. So experience tends to really ramp up your abilities fairly quickly. And that knowledge of the topic of interest and the area that you're working in and experience, they tend to make up for a lack of 1 through 4. You can do a lot more with images that are not completely appropriate. You can do a lot more without the correct tools, etc., if you have knowledge of the topic, the area, and experience. We use 7 principles or elements of image interpretation, and we will cover these in the next lecture. But just as a beginning, we look at the size of objects, either their absolute size or their size relative to other things. We look at their shape. We look for shadows and try to do interpretation as much as possible, just knowing the direction and length of shadows. Of course, we're looking at tone or color. Tone is just the grayscale equivalent of color. We look at texture, so variability in tone, pattern, repeated objects within the the images. And then we look at association, site, and location, and those are all lumped into one. And this, you're looking essentially at the existence of different kinds of objects that can give you more information. You know, particularly looking at, for instance, different kinds of industrial development. You know, if you have a power plant and it's got, you know, a big pile of coal next to it, well, it's probably a coal fire plant. If you've got oil tanks, then it's probably an oil generator. If you have none of these things, then it's either gas or nuclear, and you can just break this down one by one. Okay, and that's where we'll start in the next lecture.